Okay, so we've been discussing the use of extended regular expressions, which go beyond the normal complement available in the strict grep tools, but are supported by things like egrep or grep minus e, in doing matching for quite complex patterns that we can build up by using not only literal characters like characters such common characters, DOG, alphabetic characters, numbers, but also using these operators, these so-called metacharacters, which lend extra semantics to things. They allow us to match zero or more of something, allow us to match anything, a single character of anything, things at the beginning or end of a line, the beginning and end of a word, etc. These extended regular expressions are very, very powerful. We do have to use a special, if we're going to use grep, while these are supported by a wide variety of other things directly, such as text editors, such as programming languages, programming language libraries. If we're going to use Linux utilities, we have to use grep minus e, or use, in fact, egrep, which is a built-in command for that. Now, in my final discussions, I wanted to discuss the use of a final type of extended regular expression that involves memory, but really this is best discussed together with subexpressions. So subexpressions can be used as a key component to build up, as it were, higher level quantities within our regular expressions. And perhaps we could think of them as kind of abstractions built up as units that we can then use. So we can say, for example, that we want to match a cat or a dog, and by putting in these parentheses, we're going to be doing two things. The first is we can refer to it as a unit. So if we say, for example, this curly bracket to end curly bracket, we had seen that before as indicating that it matches it at least two times. So it's going to say match cat and then dog successively. It has to match whatever's in here at least two different times. Not necessarily match the same thing each time, but at least twice it has to match this. In this case, it's in a row. We're not separating them by anything. So, for example, that would match in Linux that word dog catcher. Dog and then cat, and also dog catchers. So here, the fact that we group these things allows us to kind of refer to them as a unit. Here, we're saying, for example, along the same lines, we match the single character C, and then we match the sequence AT at least two times. So we have to cat, C, and then AT, but we may match AT that sequence. Remember, this is not not saying match any one of them. It's saying match that sequence AT. It matches at least two times. So here's that, and potentially more than two times. Okay, at least twice. So here, C, match it twice. But there's another effect, ladies and gentlemen, associated with the grouping of these things using these parentheses. Namely, we remember what it was that was matched there. So remember, for example, what particular thing was matched in this fragment, and we can. And the key thing is here, having remembered it, we can refer to it later and match the exact same thing again. Okay. So, for example, if we have something like this, we put in this expression here, this grouping expression, this thing here. Now, it might not seem like it has an obvious value. After all, we're just having a single expression. We're not having a sequence of expressions or what have you. But it remembers what was matched here, the particular thing. So it will match, for example, if this matched C, then we'll get to A, and then it has to match whatever was matched there, so C again. Or if this matched B, get to A, match that, and then it has to match B again, because that was matched before. So if we have something like this, here, what does this do? Well, it's matching, let's again figure out how to parse this. First it's matching the word cat or the word dog, or sorry, dog or cat, one of those two, and it remembers which was matched. Then it allows 0 or more of any particular single characters, followed by what was matched before. So here we're looking for something like this first thing might match cat here, and then it will match as many of the things as is needed, 0 or more of them, until it gets to cat again. And here's cat again. So it's recognized that in this Linux.words, this line actually does match this pattern. So it had this sort of repeat characteristic sequence. Why does this \1 mean repeat? It means go match the first, what was sort of memorized by, as it were, the first of these groupings. In this case, there's only one of them. If there were 2 of them, if we got another thing in parentheses, \2 would refer to that. So here's another one. It's matched cat, and then it matches all these different things, and then that second cat. Similarly, it matches this. Oh, there's another one. Okay, there's a thing between them. It would also match cat, for example, and it matches dog, eat, dog. Incidentally, this may be a typo in it, but it certainly fits the bill when it comes to this expression, because we have a cat here, we have a cat there. Okay. And in general, there's many other constructs that can be used, quite a few useful constructs. And you might see some later in the course. I'd refer you to manuals, and there's some wonderful books introducing regular expressions if you're finding these confusing. There's some books in the O'Reilly series for that purpose. Thank you very much.